Now the sine rule for area is a formula that is used to calculate the area of a triangle if we have two known sides and an included angle. So it's a bit like the cosine rule in that sense. So the criteria for using the cosine rule is that you need to have two known sides and an included angle, or three known sides, of course. For the sine rule for area, it's the same criteria. You need to have two known sides and an included angle. Okay, so here's the diagram, okay, and here's the formula. So the formula is given as half multiplied by A multiplied by B multiplied by sine C. Or sometimes it's written as just half AB sine C without showing the multiplication symbols. Okay, so two known sides, you have a known angle, put them all together in the formula and you get the area of this triangle. Okay, so it is in fact related to the area of the triangle formula, the traditional formula, which is half multiplied by base multiplied by height. The issue here is we don't actually have a height. So the height needs to be somehow computed or calculated from an angle and from one of the known sides, and then we can come up with the height of that. I'm not going to do the proof of that in this video. That is contained in another video, so you're welcome to have a look at that if you're interested. Otherwise, let's just have a look at some examples to make sure that we're clear on how the sine rule for area works. Okay, and it's actually unrelated to the sine rule. Okay, the A over sine A and B over sine B and C over sine C. That's used for something different. Okay, this is to calculate the area of a triangle. So it's a different application altogether. So find the area of the triangle shown, correct to the nearest square meter. So we need two sides and an included angle. The problem here is that we don't have the included angle. Okay, so we need to find the included angle first. So let's call that theta. Okay, we have two other angles though. Okay, but these are no good to us. We can't use those in the formula unless we have the angle that we need, which is the included angle theta. Okay, so angle sum of a triangle, 180 degrees. Take away 50 degrees, take away 70 degrees, and we end up with 60 degrees. Okay, so this angle there is 60. Now we have an included angle and we have the two known sides on either side. Okay, so area is equal to half AB sine C. Okay, so half times 22 times 18 times the sine of 60 degrees. Okay, let's enter that into the calculator. Okay, half times 22 times 18 times sine of 60. Okay, and we get 171.47. I'm just going to round it to the nearest square meter. So that's 171 square meters. Okay. Right, let's move on to another example. Okay. Now, this one is an example of what we call a radial survey. So that's used to find the area of like an irregular shaped field, for example. And how it works is that a surveyor would probably stand somewhere in the center of the field, okay, with a compass. Okay, so there's north, and would point the compass at the vertices of the field, and would obviously indicate the bearing on all the vertices, and also would measure the distance from the center of the triangle or somewhere inside the triangle from wherever the surveyor is standing, some central point, to each of the vertices as well. So what you have here, okay, you've got there's north. Okay, so from point O to point A is 51 meters, and A is on a bearing of 033 degrees from north. Point B is 43 meters away from O, and it's on a bearing of 162 degrees. And point C is 32 meters away from O, and it's on a bearing of 262. Okay, so we almost have what we need to calculate the area of this shape. So, and this triangle ABC is really composed of these three smaller triangles. We've got triangle AOC, AOB, and BOC. Okay, so let's work out the angles first. Okay, so the angles inside each of these three smaller triangles. And once we've got those, we can then just apply the sine rule for area 3 times, add them all up together, and there's our total area. Okay, so we're treating it like a composite shape. Okay, and if you know with composite shapes, you break it up into smaller shapes, you work out the area of all the smaller shapes, and then you add it all back together again. All right, so let's give this a go. All right, so let's work out angle AOB. I think that's an easy one to work out first. Okay, and it's going to be 162 minus 33. 162 degrees minus 33 degrees, and that's going to be 129. Okay, right. So that's AOB. All right, so we've got that one there. What about BOC? I think that's an easy one to work out as well. Okay, angle BOC, it's going to be 262 minus 162. Okay, and that gives us 100 degrees. Okay, and angle AOC, okay, is equal to, we can work it out from angles in a revolution, equals, the sums to 360 degrees, minus 100 degrees, minus 129 degrees. Okay, so 360 minus 100 minus 129, and we get 131 degrees. Okay, so I think we got what we need now. Now let's work out the area of each of these three smaller triangles. Okay, and we're going to calculate the area of triangle ABC, just correct to the nearest square meter again, just to keep it sort of nice and simple there. Okay, so let's have a look at triangle AOB. We'll just go in turn. We'll just go clockwise. Okay, area, okay, is equal to half times 51 times 43 times sine of. Now what's AOB? AOB is 129 degrees. Okay, so half times 51 times 43 times sine of 129 degrees, and we get 852.1405. I'm going to work to 4 decimal places, and then I'll round it to the nearest square meter at the end. Okay, so what about triangle BOC? Okay, again, half times 43 times 32 times sine of 100 degrees. Okay, so we'll work that one out as well. So half times 43 times 32 times sine of 100. Okay, and we get 677.5477. And the last triangle is AOC. Right. Area is equal to half times 32 times 51 times sine of 131 degrees. Okay, so half times 32 times 51 times sine of 131, and we get 615.8430. Okay, the last thing we do is we just add up those three areas, and there's our grand total. Okay. And we'll do that now. So we're going to add up number 1, add up number 2, and add it to number 3, and then that's it. So, all right, I'll just write it here. So total area is equal to 1 plus 2 plus number 3, okay, which is equal to, so 852.1405 plus 677.5477 plus 615.8430. All right, hopefully got just enough space just to squeeze that in there. All right, 852.1405 plus 677.5477 plus 615.8430, and I'll get 2146. Okay, it's just to the nearest square meter. Okay. Right. Let's have a look at one last example. Okay, it says find the angles in the triangle shown, given the area of the triangle is 52 square meters. Okay, and we'll just answer to the nearest degree. Actually, no, we'll answer the nearest minute, just to maintain some level of accuracy. All right, so this time around, we're given the area of a triangle, and we're given two known sides. The first angle we can find, hopefully, is fairly straightforward, right? Which is angle C there. Okay, so let's just write down the formula for the sine rule for the area, which is half AB times sine of C, and just conveniently there, the C is what we're trying to find first. Okay, we're given the area, which is 52. Okay, half. Now the A and the B are the two the two sides that are around the included angle. So half times 15 times 13 times sine of C. Okay, and then we can just rearrange this formula. Okay, so 52 all over half times 15 times 13 is equal to sine of C. Okay, and C is then equal to inverse sine of 52 over half times 15 times 13. Okay, and we can enter that in to our calculator directly. Okay, so that's 52 over half times 15 times 13, and we get 32 degrees and 14 minutes. Okay, so I might just write that here. Oops. 32 degrees, just got to be careful not to smudge being there, and 14 minutes. So we just need to find really just one more angle if we can. Now, could we perhaps use the sine rule here to do that? The sine rule needs side angle pairs, that's the problem. So we can't really use the sine rule here, because angle B is not known, angle A is not known, and side AB is not known. So we might have to find side AB first, in fact. So why don't we do that? Okay, once we have side AB, then we can use the sine rule to find at least one other angle. Okay, I might cut the example a little bit short just so that the video doesn't go on for too long, but at least just to get it started and something for you to think about. We can't find any other angles unless we find side AB first. Okay, so how are we going to find side AB? I might just call that, actually I'll just leave it as AB. So AB, I was going to give it a pronumeral, but I'll just leave it as it is. We're going to use the cosine rule for that, okay, because we have two sides and an included angle, so we can use the cosine rule. So AB squared is equal to 15 squared plus 13 squared. Remember that one? A squared equals B squared plus C squared minus 2BC cos of A. Okay, so minus 2 times 15 times 13 multiplied by cos. Now we have an angle, 32 degrees, 14 minutes. Okay, might have to squash some of the working out here a little bit, but that's okay. The main thing is that you get the idea, all right, and that's really what the purpose of this example is. Okay, I'm probably going to run out of space anyway. 2 times 15 times 13, whoops, you can see that, yep, multiplied by cos of 32 degrees, 14 minutes, okay, which is 64.10, just move that over, yep, 0.10562684, take the square root of that, and we get, well, practically almost exactly 8, okay, so therefore AB is equal to 8.0, maybe work to the two decimal places, 8.01 meters. Might just write that in. Okay, so you now have a side. Now we have all three sides and we have a known angle. Can we now use the sine rule to find either angle A or angle B? And of course you can. So let's do that. All right, let's call this one here. Let's find angle A. Okay. So angle A. So sine A over 13 is equal to, okay, we can use this known side angle pair now, which is equal to sine of 32 degrees, 14 minutes over 8.01. Okay. Sine of A is equal to 13 multiplied by sine 32 degrees, 14 minutes over 8.01. Okay, and then we take the inverse sine of that. So I might just do the last little bit of working out here on the calculator. I've just run out of space there. Okay, so that's going to be 13 multiplied by sine 32 degrees, 14 minutes over 8.01, close bracket, and I need another bracket here. Yep, there we go. Okay, and it's going to be 59 degrees. So A is equal to 59 degrees and 57 minutes. Okay, so that's going to be equal to 59 degrees, 57 minutes, which means that now we can find angle B, angle sum of a triangle, 180 degrees, 180 minus 32 degrees, 14 minutes, minus 59 degrees, 57 minutes. Okay, and we end up with 87 degrees, 49 minutes. Okay, so this one's a little bit more involved, and it normally would have been broken up into into sections, but I just wanted to show you this, that you could apply, we just applied the area rule of a triangle, we've applied the cosine rule for finding an unknown side, and then we applied the sine rule to find an unknown angle to then sort of bridge it all together. So I guess it's great to see that relationship between all three rules, in fact, to be able to solve a problem involving one triangle.